So let me share my system so that things are a little clear when I teach. Okay, let's say we have a client, right? And we have a server, right? That is how. So let's talk one by one. Like let's start with the symmetric encryption. What happens in the symmetric encryption where we have only one key? This is symmetric encryption. Right, so let's say client want to send some data to server, right? So what it will do, it will have a key, right? So that key it will be used to encrypt the data what client want to send. And also when the data is getting transferred from client to server, this key will also be sent along, because there is no other way server will know the key, right? So the key will encrypt the data and also be sent along with with the data in the network, right? And then once the server receives the data along with the key, the same key will be used by the server um, to basically decrypt it, right? And that is how the communication happens. The client will send some data in the encrypted format, and then it will be received at the server end, and that can get decrypted using the same key. Now the issue here is, so what an attacker can do is basically like a man in the middle attack, right? You might have seen man in the middle attack, MMA attack. So what they can do is basically the key is also getting transferred, right? So if they get to know the key, they can decrypt this data, right, easily. So that is why this is not safe. Right. So what we do, we use say asymmetric encryption, right? So what asymmetric encryption does is let's say we have this client, and then we have a server, client and server, and then basically this client this server will say, hey, this is my public key, right? So let me add uh, it will have a public key and it will have a private key as well, right? Private key. Right. So what server will do? Server will say, hey, this is my public key. Okay. So public key can be shared with anyone. So even if the attacker in the middle try to try to take the public key, doesn't matter, right? Because public key is only meant for encrypting the data, not for decrypting the data, right? So the server say, hey, this is my public key. Whenever you send your key, right, please encrypt it using my public key so that I have a private key to decrypt it, right? So the client basically has its own key as well, right? Which is client's key. So what client will do, and a data as well, right? Right. So what client will do? Client will basically encrypt uh, the key using the public key, right? And then send it to the server. Key, hey, this is my key which I have. This is basically a symmetric key in such a way that MMA attack does not happen. So the idea is like, how do we transfer the symmetric key to the server? Like both the parties should have a key so that the data can be transferred. Because if we keep on doing every time this public key, private key, public key, private key for the data, the system will be very slow. Even that can be done, but it will be slow. So what we try to do is like we try to transfer the key securely to both the party. This key is basically symmetric key only, to both the party in such a way that after once both the party have this symmetry key, then they can transfer the data properly using the symmetric key only, like the same approach, right? um so that this client will basically encrypt the key and then transfer it to the server. Now server can decrypt the key because only server has the private key, right? The client, man in the middle attack won't happen because uh, this they don't have private key, and this can only be encrypted using a private key, decrypted only a private key, right? So man in the middle attack is not possible, right? Once both the party have a key, now they can now like client, whenever client want to send the data, it will encrypt the data using the key, but he won't send the data, he won't send the key over the network, and then when the server receives the data, server will decrypt the data using its the same key, because server also have that key, right? Can somebody tell me, like, still MMA attack possible in this case? Yeah, it's possible. How? I will tell you. And that is how the authorities like Let's Encrypt and all other GitHub authorities like solves this problem. You might have seen in the website like SSL certificates, right? Why do we need certificates? I mean, like, if the system is this secure, or like everything is secure, then why do we even need a certificate, right? No, it is not properly secured. That is why certificate basically secures the whole system. I will tell you like why. Like, let's say when the server is trying to send public key to the client, there can be a chance that the man in the middle attack, the person who is trying to, attack our system, they will keep the server's public key, and they will give their own public key to the client, right? There is a case, right? And when client will give the encrypted key to the over the network, this they can basically, because they will have its own public and private key, right? So they can decrypt this key, and then they can harm the system, because they are basically sitting in the middle and then spoofing the public key, and then sending their own public key instead of the actual server public key. They will also have their own public key and private key, right? uh, Public key and private key, right? So they can also spoof the data, I mean, like, harm the data, right? So how do we solve this problem is, big authorities, right? Like, for example, one of the authority I know is Let's Encrypt. What they do, now here comes the picture of certifications, like you have seen SSL certificates and all, right? So here comes the picture of certification. How this will be solved is like, the server, let's say this domain is abc.com, right? And then this domain, this server basically will go to Let's Encrypt, uh, encrypt, and what they will say, and Let's Encrypt will have its own public and private key, right? They will have their own public and private key, Pub- public key and private key. So Let's Encrypt will say, hey man, I have my domain is abc.com. They will basically give so many details about their domain, that it's abc.com. This is expiry date, and this is all the other details. This is like where it is hosted, and I don't know what all details they give, but yeah, they give a few details. And what Let's Encrypt will do that, and also this domain, this server will give its public key as well, because public key is shareable to anyone, right? Even the man in the middle attack can have a public key, right? Because it is only used for encryption, not for decryption. So they will share their public key, and then what they will do, Let's Encrypt, what it will do, Let's Encrypt will basically create a certificate, signed certificate with all the details saying that for this domain, for abc.com, uh, this is a certificate, signed certificate, and the identification for that certificate is basically public key, server public key plus Let's encrypt public key, right? That is how a certificate is signed, right? Okay. Now what will happen whenever server, so this certificate is signed, and it's been kept with the Let's Encrypt organization, right? So whenever server try to send its public key to the client, uh, the man in the middle attack can basically spoof the public key and send its own public key, right? Now, whenever server send this to a client, let's say, so it will also send a certificate. along with it, right? This is the certificate, right? Even the man in the middle attack can spoof the certificate, right? So when the client see the certificate, SSL certificate, it means that basically server is saying, hey man, I'm sending the certificate. Please verify that with the organization who has signed the certificate, right? So their job is to send the certificate and the client job is to verify the certificate. So when the client will receive this certificate, right, SSL certificate, what it will do, it will go to Let's Encrypt and it will say, hey, can you please give me your public key, so that I can verify the certificate which I've got is correct or not. Because the certificate is what? A combination of server public key and Let's Encrypt public key. Server public key is anyway sent by the server and is asking for your Let's Encrypt public key, right? So Let's Encrypt will say, okay, for this particular domain, client is asking my public key, I will share because public key is shareable. Again, I'm saying the same thing, right? Um, it will share this public key to the client, and client have a server public key. Client will try to do the same, use the same algorithm to verify the signed certificate, and if it matches, uh, it means like, yeah, the certificate is valid. And let's say, and now man in the middle attack won't happen because this certificate won't be valid. Even let's say the data was spoofed or the public key was changed in the middle, right? So that, because this public key will be different and the client, whatever public key client is sending will be different, so certificate will not match. So that is how the whole encryption and decryption works, and that is how the whole purpose of SSL certificate, how your data is encrypted and securely traveled over the network and all those things. I hope like this session was useful to all of you and you have learned something new in this. Um, Thank you.